Welcome back. In this video, we are going to solve problem 6-143 that is taken from chapter number 6 bending and book name is Mechanics of Material by RC Hibbeler 9th edition. And the topic that we are covering here is curved beam. So statement is the elbow of pipe has outer radius of 0.75 inch and inner radius is 0.63 inch. If the assembly is subjected to movement of 25 pound into inch, determine the maximum stress developed at section AA. So you can see this is the elbow of the pipe and the cross section is shown over here. Outer radius is 0.75 and inner radius is 0.63. And what if it is applied with a movement of 25 pounds into inch? So you have to determine the stresses, maximum stresses in this elbow at section AA. So you can see that maximum stresses will be always at top or bottom layer. And you can see this elbow has a curvature of radius 1 inch. The side, if you cut it, the side view is also given over here. So you have to determine the normal maximum stresses at this point. Let this is your point A and this is your point B. Clear? So let's start with the solution. As we have already, movement is 25 pound into inch and formula used in this curved beam or stress is equal to movement into capital R minus R divided by A into E into R. And what is capital R? So capital R is distance from this center of curvature till the point where its neutral axis lie, that is capital R. And R dash is distance from the center of curvature till the centroid. So this is R dash. Clear? And area is the cross-sectional area of this pipe, which is hollow pipe. This will be the area. And E is obtained by R dash minus capital R. And R is distance from this centroid, center of curvature, to the any point where you want to find the stress. So here we are going to find out the stress at RA and at RB. So let's start the solution. So we will need this R dash. What is R dash? So you can see if I proceed this center of curvature and axis that is passing through center of curvature, as this is the side view from this side. So you can see center of curvature will be exactly at this point. This is your center of curvature. And the distance from center of curvature till the centroid of this section, this distance is known as R dash. I will mention it over here. This is your R dash. Okay. And this R dash, you can see, I will write it over here. This R dash is equal to distance from this center till this point. This is 1 inch already. And the out this radius, which is 0.75. So total is 1.75. So I will write it R dash is equal to 1.75 inch is equal to 1.75 inch. Now we will find this capital R. So how you will find this capital R? So for capital R, you can see this capital R is equal to area divided by integral of dA over R over entire area. So first we will find this area. So you can see this is a hollow pipe having outer radius 0.75 and inner radius 0.63. So for that we have formula that is equal to pi C outer square minus pi C inner square. So put the value, you have C outer which is 0.75 and C inner is 0.63. So pi into 0.75 square minus pi into 0.63 square. And when you solve this, you will get area will be equal to 0.1656 pi. You can multiply 0.1656 with 3.1417. So you will get area and the unit will be square inch. Now what about this term dA over R for the entire area? So for that we will take the help of table 6.1, where in one column you have shape and another column you have formula integral dA over R for the entire area. As we have circle, this is solid circle having dA is equal to 2 pi into r dash minus r dash square minus c square. But this formula is valid for solid shaft or solid cylinder. Clear? For circular rod or pipe, I will write pipe. This formula will become equal to integral of dA over r for entire area will be equal to 2 pi into r dash minus r square minus c outer square. For c outer minus 2 pi into r dash minus r dash square minus c inner square. Why? Because we are going out to find out this section of the formula for this section. Clear? Not the hollow term. So now you just put the value 2 pi r dash was 1.75 minus under the root 1.75 square minus c outer is 0.75 square. Okay. Minus 2 pi into r dash is 1.75 minus under the root r square, which is 1.75 square minus c inner is 0.63 square. Okay. So when you solve this, you will get the term dA over r for entire area for this hollow pipe or elbow comes out to be 0.323758 inch. Okay. Now you have the value of A and you have this term. So just plug it in this formula. So we will get this R. R is equal to A. A is how much? 0.1656 times pi divided by this term 0.323758 inch. This one. Okay. So when you solve this, you will get this capital A will be 1.6069 inch. Okay. You can see that your neutral axis will be always lesser than the centroidal axis. So it will be somewhere here. So this will be your R. R is distance from center of curvature till the point where neutral axis lie. So this blue one is its neutral axis. Okay. This is capital R. Now you have all these things. Just find E. E is equal to R dash minus R. So E is equal to R dash minus capital R. So R dash is already we have find out this is 1.75. So 1.75 minus R is 1.6069. So when you solve this, you will get R will be equal to 0.143097 inch. Now you have all the value, just plug it in this formula. So for point A, this is your point A. This is your point A. This small r will be equal to RA for point A. And for R is equal to this point B. This R will be equal to RB for point B. And we know that RA is distance from center of curvature till point A, which is 1 inch. And RB will be equal to this distance. So 1 plus this diameter, which is 0.75 plus 0.75 is 1.5 plus this one is 2.5. So write down here RA is equal to 1 inch and RB is equal to 2.5 inch. Okay. Now we are interested to find out the stress, maximum stresses. So for point A, this stress will be equal to sigma A, and that is capital M into R minus RA divided by area into E into RA. So put the value M is given as 25 pound into inch. So 25 multiplied by capital R is 1.6069 minus RA is 2.5. Clear? Divide by RA. RA is 1 inch. Okay, so let me correct it. This is 1 inch. Divide by area. So area is 0.1656. 0.656 multiplied by pi. E is this one, 0.143097 multiplied by RA is 1. So when you solve this, you will get stress at point A will be 204 psi. As the value is positive, so it means that point A is in tension. This is the value of point A. Now what we will do is that we will find the maximum stress for point B. So for point B, stress at point B will be equal to capital M into R minus small rb divided by A into E into RB. So plug in the formula, plug in the value. A moment is 25, capital R is 1.6069 minus RB is 2.5. RB is 2.5. Divide by area, which is 0.1656 times pi, multiply by E is 0.14309 and RB is 2.5. So when you solve this, you will get stress at point B comes out to be minus 120 psi. Or you can see stress at point B comes out to be 120 psi. Negative sign means that point B is in compression. Okay. And that is the answer of our this question. So this was all about this problem 6-43. I hope you have enjoyed this video. This video was requested by one of the subscriber to solve this curved beam when there is an angle. So I have solved this. I hope you have liked this and you are learning as well. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching and supporting me.